What's up, guys? This is Brad. I got a quick tutorial here on how to show you how to make a realistic turret using Raycast. And so let's jump right in. So for starters, let me explain to you what I have going on here. I have a turret that I've created. I modeled it myself using Blender. And I created a separate part, or an entire prefab, I guess. Basically, what it is I took the import, this is the import. This is what it looked like. It was three separate meshes inside Blender stuck together to look like a turret, and I dropped it here in the game world. I pulled the cylinder out, and I created an empty game object, and then I put everything back into that empty game object. So basically what it did was it's separated the base from the top of the turret, not the capsule, the cylinder is what we need. So it separates the base from the top of the turret. So basically you can apply a chase script to the top of the turret to make it chase the player while the base stays stationary. So it basically gives it a rotation point, if you will. So going down here, I have a script attached to it called turret behavior that has the chase behavior in it, and I'll show you what that looks like. Let me zoom in here. So your first variable is a look at target. It's a transform. This is basically going to call within the game world. It finds an object with the tag player, which is my capsule. My capsule has the player tag. That's very important. And it gets the component transform, which is basically the position, the rotation, and the scale. And then on every update, it calculates the distance to the player using this built-in Unity function, vector3.distance. You give it a start point and a finish point, and it will calculate the distance for you in and I believe it'll return a float, but it could be an int. I could be wrong. So I have my look at target.position, which is the player, and I also have the position of the turret. So the position of the player from the position of the turret, and that's your distance to player, and that runs on every executed the update function, just so you have a constantly updated distance to the player. And from here, what it does is you initialize a range. The range is set to 75 units within the game world, and so if the player is within range of the turret, so if the distance to player is less than or equal to the range of the turret, which I initialized as 75 units, the turret will track the player using this function. This isn't the actual function, this is the functionality of it, but what you do here is you declare a function called rotate, and this basically uses the quaternion functionality, and this is used to set the final rotation. So this is what your rotation would be if you were looking directly at the player. And then when you apply your transform.rotation, you set your rotation. You use a quaternion.slurp function. The slurp function is really cool. It basically, you give it a start point and an end point, which, remember, if you remember, the rotate is the rotation that you're trying to get to if you're looking directly at the player. So this would be your start point, your current rotation, and your end point, which would be your desired rotation, and then you give it a time variable, and it automatically, I guess, would blend from the first rotation to the end rotation. And I'll give you a quick look at what that looks like. Oh, real quick, I also applied a basic player function just to give you a little bit of movement. It just uses a translate function, and then it also has a rigid body attached to it to simulate gravity, to and then the scripts attached to that. So this is what it looks like. So basically what you're supposed to have is when you're out of the range, which you see the player is out of the range because the turret's not tracking it yet, the turret goes to an idle value. But when you step within the turret's range, it starts to chase you. And I have a rotation dampening variable attached to it, so it doesn't stay exactly perfectly with you, because that would just be unfair for my point of view. But you can see it eventually catches up with the player. So what I wanted to do is I wanted, instead of using the mesh collider or the capsule collider, sphere collider, what have you, of the turret, I wanted to use raycasting to, since when the turret is essentially looking at the player or has locked onto the player, and then I want it to fire. So to jump through that real quick, hang on just a second. Alright, so to add the functionality of the raycast, we need to go back into the turret behavior script. I'll maximize that. So what we want to happen is when the player is within the range of the turret, we want the turret to look at the player, and we want it to send out a ray. So first we have to declare a raycast hit variable, which we'll call hit. And this is basically the collider variable. This is what the raycast is going to pull out of what it has a collision with. So if physics.raycast and this will check to see if there has been a collision with the ray that's being cast. So this says if there's a collision with the ray, and then you want to declare your ray here within the if statement. So we'll do transform.position, which will be the initial point. This will be the origin of the array. Position. And then we want to give it a direction value. So real quick before we continue with that, we're going to go ahead and declare a forward variable. And we want this variable to constantly update to the forward location that the turret is tracking to, not the overall direction that the entire turret is looking at, but only the head of the turret. So when we work with it here, we're going to say forward equals transform rotation. Transform direction, I'm sorry. And it's going to be vector3.forward. Alright, so we go back down into our raycast, and we want our direction to be in the forward direction. And this means that it will always be shooting the ray in the forward direction from the origin of the turret, and that's set by this function here. So now we need to give it a what's the word? So now we need to give it the raycast hit variable, which is going to be returned, which we already declared. That's hit. We pull it from there, and then we need to give it a distance. So how far the ray is going to protrude from the origin in the direction that we specified. So we want that to be equal to our range. So continuing with our if statement, if there's a raycast collider, if there's a collision with this ray that we fired out, if it is equal to the player, so if hit dot collider dot game object dot tag is equal to the player, we want it to perform a shoot function, and this would be your basic shoot function, whatever you wanted to instantiate. You see I've already declared it down here. Normally you would have this like instantiate a bullet or a missile or cannonball or whatever you're working with, a fireball, but right now for simplicity I'm just going to give it a dlog or debug log statement, so we'll know if there's been a collision. That player. So this will basically come down and pop up in here saying that we need to shoot at the player at this time, which is when the collision takes place. So we're going to save that, go back to the game. Oh, we need 2 equal signs there, excuse me. Alright, so right now you're out of the range. Sneak around to give you a little view. And when the player locks on, there we see that it's having a collision with the ray. To better help you visualize it, I'll show you a quick way. For debug purposes, this is really only practical. This isn't going to give you a way to view the ray within the game world, but it'll give you a good way to view the ray within your scene pane here. But note that it doesn't show up in the game screen. So basically the idea behind it is it's another debug function, and it's pretty much going to look like this. So you're going to do debug.drawRay, and it's a little different from the Raycast function, but it has some similarities. So you want to set the origin, transform.position, and the direction and the range are declared in the same statement. So we'll say forward times range. So it's going to shoot in this direction at that range. And then you want to give it a color, so we'll be able to see it. So we'll do color.red. And you should see it appear here in your game window. So that's what your ray would look like if it was casting, but note that it's not casting now because it's not tracking the player. But we'll go down and you check it out. See, it runs over. Because of the dampening I had, it's not chasing me perfectly. But you see when it collides with me, right there, it's giving me the feedback. So when I go back out of the range of the turret, it dumps back off to its original position, its idle position. And there you have it. It's a cool, interesting little turret. Thanks for watching.